Okay, welcome back to the SSAS training sessions. In last sessions, we discussed about aggregations, how to create the standard aggregations and how to create usage-based aggregations, and how the query will make use of the aggregations created while querying the data. Now, in this session, let's talk about the concept storage mode. What is storage mode at first place? So, if you remember, when I said this is my underlying data source and this is my application, and when I process it, it reads the data from here and it stores in the analysis services. So in this case, the analysis services is my storage mode. So the storage mode is nothing but where the data and the indexes and the aggregations will be stored when you process the analysis service project. So by default, there are three types of storage modes which you can set for a partition or for a dimension too. The first one is molap. The second one is rollup, and third one is whole-app. So the molap is the default one. When you open a new project and if you don't make any changes to the storage modes in the cube or in the dimensions, then by default it will be molap and the storage mode will be taken as molap. So molap stands for multidimensional OLAP, whereas rollup stands for relational OLAP and whole-app stands for hybrid OLAP. Now molap, when you select molap, the data will be stored in the analysis services format. That means this is your relational database, this is your project, and this is your analysis server. So the data will be stored in the analysis server when you click on process by selecting the storage mode as molap. I have shown you a couple of times, like if you go to the folder C drive, in the C drive, program files, Microsoft SQL Server, and SSAS, under that OLAP, under the data, you can see a folder, database folder created like AdventureWorks dw.db, in which you can see the folder with the cube name .cub extension. In that you can see a lot of partitions created and the data in the partitions. Basically it stores in the form of binary files when you select molap and process the database. The second one is rollup. If you select rollup, it won't use this storage at all. The data will be in the relational database side and the aggregations will be created on the relational database side. So it won't take the help of analysis server side. So the advantage of this one is you don't need any extra space to store all the processed data. And the third one is whole-app, whole-app, which means hybrid OLAP. It is the hybrid of molap and rollup. So in whole-app, the data will be here and the aggregations will be created on the analysis server side. So it takes use of both the storage modes on the different side, on both the ends, like relational and the analysis services, and it uses the data from the relational and it creates aggregations on the analysis server side. Now let's say this is your relational side and this is your analysis server side. If it is molap, whatever is selected for the processing, what it will do is it will read the data and it create the indexes and it create the aggregations. So if you select molap, everything on this side, on the analysis server side. If you select rollup, everything on this side, that is on the relational side. And if you select whole-app, data will be on this side, but aggregations will be on analysis server side. So it's a hybrid of rollup and molap. So these are the different storage modes that are available in analysis services. In very shortly, we'll see how we can change the storage mode of a partition or a dimension. Before going to that, let's try to list out all the advantages and disadvantages of these three storage modes. So for that, let me take Notepad and let me select molap first. So molap, data and aggregations on analysis server side. Now let me take rollup, data and aggregations on relational server. And the third one is whole app. So if you take whole app, data on relational and aggregations on analysis servers. So this is how the storage will be used if you select a mole app or roll app or whole app. Now if you see the advantages of mole app, the data is pre-processed and the data is aggregated and it's stored in, and it is also compressed and stored in the analysis server side. So it won't fire any queries to underlying SQL if you execute an MDX on mole app cube. So what will happen is the performance, to be specific, it is query performance will be good, will be super good. Here the advantage is it's a real-time data. It is, I mean, real-time data in the sense, this is your underlying data warehouse, and this is your analysis server storage, and this is your application. So if you select mole app, what will happen is you need to process every time when you get new data here. Let's say I have 1000 records. You need to process. What it will do is it will read the data from here and it will write the data to analysis server if you select the storage mode as mole app. And let's say 10 records added after you last processed. These 10 records will not be available on the analysis server for querying until you reprocess again. And let's say there are 3 more records added. Again, you have to process. So every time you need to process to get the data live, or to get the newly added records live. So that means this is not real time. These analysis services, if you set it the storage mode as small app, the cube is always outdated. If I process the cube today and after 1 year, if I come and see the data in the cube, it will be the same data that was available when I last processed. So that is why we call it as outdated, always outdated. It will be real time only, or it will be updated only when you processed it, or rest of the time it will be outdated cube. That is the major disadvantage of mole app. So the advantages of roll app on the other side is it's real time data, and even for whole app it's real time data because it reads the data from the relational database directly. So the data is real time. And let's talk about the disadvantages too. Here one more advantage is there in roll app, that is processing time is very less. That means the data will be in the relational database, the aggregations will be created on the relational database, and you don't need to read all the data that is available in the relational database to the analysis server side in rollup. That is why it's a super good advantage. If you try to process a 100 GB sized molap cube, by changing the storage mode to rollup, it takes only 1 to 2 minutes. Because it don't need to read the data, it just need to create the aggregations if required, the two on the relational database side, nothing on the analysis server. So the processing time is very less. Even for whole app it is very less because it doesn't it don't need to it's not required to read any data from the relational database to the analysis server side. Here that is the biggest disadvantage. Processing time is very high, depends on data. If you have huge data in your relational database like 1 terabyte, then it will take a lot of time to process and read the data and compress the data onto the analysis server side. So the only and the main advantages is query performance on molap, whereas the main advantage is the processing maintenance will be easy. You don't need to spend hours to process the cube, and also you don't need to wait for the data. Wait for the cube to process to get the real-time data. It's always real-time. Now let's see the next advantages or disadvantages. Here it takes more space, more storage required on the analysis server side too. Here no storage required on the analysis server side. For the whole app, as I said, the aggregations will be on the analysis server side. You may need little storage to save aggregations, because aggregations will be on analysis server side if you select OLAP. So these are the major advantages and disadvantages, and let me think of anything else here. Yeah, here one more advantage, sorry, disadvantage. I didn't mention it. No real time. Here under disadvantages, query performance is very poor. And here query performance actually it depends. It's very poor if you query leaf level data, and good as MOLAP if your query can be evaluated by using the aggregations. Okay. So that means I said that aggregations will be created on the analysis server side, and if you trigger a query, let's assume you send a select product on 1 comma sales amount on 0 from the cube name or the database name, sorry, cube name. Then if there is any aggregations created for the product name and the sales amount, then it will go and fetch from the aggregations and it will display the data. So it will be super fast if you're querying, if your query can be evaluated by using the aggregations that are created on the analysis server side in under whole app storage mode. So these are the disadvantages and advantages of each storage mode. If you see, it's more like one advantage is disadvantage of the other. Mainly the real time is the biggest advantage of roll app and whole app, whereas it's the biggest disadvantage of mole app. And the second one is query performance is pretty good. So users are very much interested in these two. They don't care much about storage. They can provide like 1 terabyte, 2 terabyte of SanDisk, but real time, they expect real time, and they want query performance, and they don't want downtime, like downtime in the sense the processing. While processing is going on or commit phase is going on, they cannot query the cube, or in that case, so these three are very, very important to the users. And even downtime, the processing time can be adjusted by taking a work window on weekends, like okay, this weekend on Sunday from 9 to 12 we'll be processing the cube, and we'll send out a mail saying that there's a downtime, the cube cannot be accessed during the period. So that can be handled, like one processing is not a frequent or regular activity, right? So you can handle that, but the major issues are like query performance. That is what users are very much interested in, and the real-time data. So if you see these two things that user want from us, the first one is query performance. You can get it only if you use MOLAP, and the second one is rollup. If you use rollup, then only you can use real time. So how can we merge these two and make our user happy? So there is no option to improve the performance here, or the only option is use some underlying database servers which are good in performance, like Greenplum. Greenplum is far better in performance than other database servers. So people are using Greenplum as their data warehouse instead of SQL Server, Teradata, Sybase, and DB2. So if you build your cube using Rollup on top of the Greenplum database, then the performance is very much better. The querying is very faster if you query from Greenplum, and that is one solution. But this performance can't compete with the performance that you will get when you use MOLAP storage mode. So that is one thing. Either you can go with Greenplum or such kind of databases servers. Not only Greenplum. I'm not advertising Greenplum here. I'm just telling you an example. There are a lot of databases in recent past which are pretty good in querying performance. So you can go with good performance underlying data warehouse and use rollup storage mode, or go with MOLAP storage mode and pick proactive caching option, which will give you pseudo real time. It's not real time data, but it's a pseudo or indirect or some other way to tries to get the real time data. So we'll be discussing about the proactive caching option, which is very important to understand and keep an idea about. So MoLab, I have seen like 85 to 90% of the users using this, and recently the growth for Rollup is very much high compared to MoLab. In recent past, I've seen a lot of users opting for Rollup databases, and Rollup it's not much used. I've never seen users requesting or using Rollup storage more. Now, let's concentrate on proactive caching with MoLab. So proactive caching along with MoLab will improve the query performance and also provide us real-time data, very close. As I said, it will be pseudo real-time data. Before going to that, let's see how and where we can set the storage mode of a partition or a dimension. If you go to the dimension here, and if you go to the properties, there will become something called two storage mode or two properties related to storage mode. One is storage mode and another one is current storage mode. This is read only, you can't do anything. And the storage mode here, I can select memory, MOLAP, ROLAP and in memory. And the same way you can go with, the suggestion for dimensions is to go with MOLAP. So recently, a couple of users asked me, why don't we go for roll up so that everything will be quite real time? But we face a lot of issues if you go with roll up dimensions. So my suggestion is to go with molap dimensions and roll up partitions, because dimensions will be very small and you don't need to spend much time to process. But the time taking one is always partitions or the measure groups, where you'll be having millions and millions of data, and it will be taking a lot of time to read the data and then to create the aggregation. So my suggestion is to go with the ideal case, which a lot of users prefer, is like molap dimensions with rollup partitions. Now for partitions, you can come here and you can see the storage mode. You have to pick the partition for which you want to change the storage mode. Let's see, in the current case I want to change the storage mode of the partition fact internet sales. So then you have to select storage settings. Once you select storage settings, you can see seven different options, five related to MOLAP. If you see, all these related to MOLAP, and one is HOLAP and another one is ROLAP. So you can use this slider to select either MOLAP, ROLAP or HOLAP, something like that, or even medium latency MOLAP, scheduled MOLAP, which we'll be discussing about shortly. So these are the different options you can set. And if you see here, when you select an option, when you slide to the MOLAP, you can see the description about it. Measure group data and the aggregations are stored in the multidimensional format, and notifications are not received when data changes. That means if there is any data change in the underlying database, okay, on which the cube database is built, it won't notify the analysis server saying that, oh, there is two new records added to the table, do you want to fetch this data? Nothing like that. It will not be notified. It is like more like a dead or independent one. Until you process it, it will be always outdated. No notifications will be allowing analysis services saying that there is a change in the data in the table, and no action will be taken by the analysis server. And processing must be either scheduled or performed manually. That means you have to process it manually, or you have to create a schedule to trigger it every day or every week or every month, depends on the requirements. So if you select MOLAP, it's more like everything manual. No notification, automatic notifications, no automatic actions will be taken on processing the data. The second one is scheduled MOLAP. So for all the MOLAP stuff, the first point will remain the same. The first point, in the sense, the measure group data and the aggregations are stored in the multidimensional format, because all these are MOLAP. The second one, if you see, notifications are not received when data changes. So it won't care about the notifications, or it won't get the notifications, but processing is automatically performed every 24 hours. So this is automatically performed every 24 hours, and you don't need to come and do it manually. So if you select scheduled MOLAP, if you select automatic MOLAP, You can see measure group data and aggregations are stored in multidimensional format. The server will listen to the notifications when data change. That means when there is a data change occurred, then the server will get the notification saying that the table data is changed. So what you want to do? Processing is performed automatically with no restriction on latency. So we'll be discussing about this latency and all. So processing will be automatically performed based on the time interval we provide. And medium latency is like everything same. The notifications will be heard or listen the notifications when data changes, and processing is performed automatically with a target latency of 4 hours. So this is one option. So and the fourth one is target latency will be different here. It will be only 30 minutes. Apart from that, the remaining stuff is same compared to the medium latency MOLAP and automatic MOLAP. And if you go to whole app, measure groups data are maintained in the relational format, and aggregations are stored in the multi-dimensional format, and the server will listen for the notifications when data changes. All queries reflect the current state of data. That means all the queries that you trigger will get the current status of data, like whatever the data that is available in the SQL server or the underlying database, it will be displayed in the when you trigger an MDX query. So basically this real time is, this is your relational database and this is your analysis service database and this is your report. Let's say if you query a report and the storage mode is MOLAP or anything related to MOLAP, it will hit here and get the data to the report. Okay, but in the other case, if you select MOLAP and let's say this is the project, okay, the SSAS project, and if you select roll app or whole app, what will happen is it will go to the project and it will see whether it's a roll app, MOLAP or whole app. If it is roll app, it will come and it will hit this relational database engine. That is why the data will be always up to date, like it reflects the current state of data. That means whatever the data that is available, whatever the data that is available in the relational database, that will be shown in your reports. That is what he means here, the current state of data, or in other words, the real-time data. And if you go to roll app, the only difference between real-time whole app and the roll app is the storage of the aggregations. In whole app, the storage of aggregations is on analysis server side, whereas in roll app, the storage and as well as the data on the relational database side. And whenever you select anything, let's say the automatic MOLAP, and if you click here, it will give you the options, different options, or you can set the options manually by going to the custom settings options. Okay, now these options will say when the notification received and what to do when the notification received and how to act when there is a data change notification and what is the way that I get the notification. All the information will be in the storage options. Let's see each and every storage option. The first one is storage mode. It's the default one like MOLAP, ROLAP and WHOLAP. If you select MOLAP, then you can enable the proactive caching. So this is what I was talking about, proactive caching, which will provide pseudo real time to the MOLAP storage mode. If you disable it, it's more like MOLAP. If you enable it, it should fall into either one of these, like medium latency MOLAP or automatic MOLAP or scheduled MOLAP or low latency MOLAP. So MOLAP with proactive caching is nothing but these four. Okay. If no proactive caching and the storage mode is MOLAP, then it is this. Oops, sorry. And the remaining two are independent. You know those are real-time whole app and real-time roll app. Now let's see the different options that we can set in proactive caching. If you go to the options, the first thing you need to do is to check the enable proactive caching to make general and notification tabs enable. If you don't check this or enable this, then everything will be disabled. Okay, now first let's talk a little bit about the notifications and we can revisit this. So this notifications is the way that analysis server or the analysis server will be notified, like there is a change in the underlying database. Okay, there is a table which is used to build this particular fact table, that to build this partition, that is fact internet sales. So these notifications is the way that it will listen to the changes that are occurred in the table, which is used as source for creating this partition. If you see this partition creation, the source is fact internet sales table. So if you specify the same here, the analysis server can listen to the changes in the table so that it can act. Okay, there are changes, do something to read those changes and store those changes somewhere in the analysis server so that the MOLAP can become very close to real time. Let's say this is your relational database and this is your project and this is your analysis server. So when you process it, it reads the data from here to here. That is one job. And the second one is this analysis server project should continue to listen the changes. If you enable the proactive caching, it will get notified when there is a change in the database. So then it has to bring those changes and store somewhere here on the analysis server so that when the query is triggered, it should also get the changes that are occurred in the relational database after the last process time. So this is the main purpose of notification. Notification will be alerted continuously, like if there is any changes occur, then this analysis server will be notified, and once it is notified, then this general cache settings and all will come into picture to read the changes and store in the cache. Let's talk about the different options here. Okay, so if you see the changes are, if the changes are identified, and let's say this is your analysis server storage where you have all the fact and the dimension information. So in the same server, it will use the cache, MOLAP model or MOLAP cache. It will create a MOLAP cache and it will read the changes. This is your project and this is your relational database. When you process it, it will go here and it will read to this. But when the notification triggered, the change occurred in the SQL server or underlying database, then the changes will be read to the cache. Okay, the cache is very important, the temporary memory. And when you trigger an MDX query from your application, it will check the data here and it will check the data here and it will read the data from both the storage locations. That is how the processed data as well as change data, recent changes, will be displayed in your report, and we call it as pseudo real time. It's not 100% real time. That means it is in cache, temporary memory. It is not in your analysis service storage mode, but it is in temporary memory, which will be used to display data in the reports. So that is why we call it as pseudo real time. Now let's talk about different options here. The first option is update the cache when the data changes. So that means when the notification triggered saying that there is a change in the table that is used to create the partition, then it will update the cache. How it will update the cache, when it will update the cache will be determined by these two properties. It's not like whenever there is a change, for every one record it should not read into the cache. It has to wait for certain period of time, right? So the first one is silence interval. This is the minimum time that analysis server will wait to read the changes from the relational database to the cache model. Okay, this is the minimum time. Let's say at at the current time, I got a notification saying that there is a data change in the fact internet sales. Then it will wait for 10 seconds. I have given 10 seconds, right? Silence interval. It will wait for 10 seconds, 5, 6, 7, 8, 9. And in the 10th second, if it gets one more notification, so that means the data is continuously changing, and once it changes, let me wait for at least 10 seconds. If I don't hear anything, then I'll process. So here, let's say there is one more data change notification, then again it will start waiting for 10 seconds. The silence interval is like keep silence for this period of time when you hear the first notification. And if you hear one more notification in this interval of time, then wait for 10 more seconds from that particular notification time, right? So let's say after 10 seconds, until 10 seconds, there is no notification saying that the data is changed. Then here the data reads the data, the server reads the data from the relational database, the change data to the cache on the analysis server side. So this is called silence interval. The silence interval is like to keep shut for a period of time after you receive the first notification. If you receive another notification, then wait for some other time. I mean, wait for 10 more seconds, or wait for the same duration starting from the second notification time. And if it hear one more notification within 10 seconds, then it will continue to wait for 10 more seconds from there. So it's a continuous process. Okay, that means it is the data is coming, the new data is coming, or the data changes are occurring for every 10 seconds. So why don't I wait and read the data at a particular point of time when I don't hear any notifications, or when there is no data changes on the server side, relational database side. So the silence override interval is okay, continue to do that, and that means wait for 10 seconds. And if you hear one more notification, wait for 10 seconds. If you hear one more notification in the 10 seconds, then wait for 10 more seconds, wait for 10 more seconds, and so on. If it wait for 60 times, then it will be 10 minutes, right? So if the data is continuously coming for every 10 seconds, or even 5 seconds, then it cannot process, and at the same time it cannot continue to hold without reading the changes. If it continue to hold reading the changes for more than 10 minutes, then there is a latency of 10 minutes, right? The data added 10 minutes before into your database, but it is still not available on your analysis server. It is not real time. So this override interval is, it says that okay, if you continue to hear the data change notifications, or if you continue to get data change notifications for more than 10 minutes, then stop it and process it. So this is the override, this is the breaking point, this is the threshold time you can continue to hear the notifications. And once you reach this threshold value, then process the data and read the data to the cache, so temporary memory. And this data will be available to the analysis server users, like who query the analysis server databases. So the silence interval and the silence override interval decides like how long it has to wait and what is the threshold value to wait. That means it cannot wait, it cannot continue to wait for days, right? If it is getting notifications for every 10 seconds for 2 days continuously, then it cannot wait for 2 days, which becomes the outdated data and no real-time data on the analysis server side. So the override interval also very important, which talks about what is the threshold value that it can wait before processing the caching. So this is about update the cache when the data changes. This is purely depends on the notifications. Okay. Now drop outdated cache. Let's say a cache is built. It reaches the threshold and the cache is built. Let us call it as cache 1. And this is your analysis service database, and the queries will be pointing to these two. Okay. Now drop outdated cache. If you check this guy, you need to set some interval like latency, let's say 30 minutes. In that case, what will happen is, let's say this again, once the cache 1 is built, what will happen again? It will start listening to the notifications, and it continue to listen the notifications. Let's say for 10 minutes it continue to listen the data change notifications, and the threshold value is reached. What it will do is it will start building the new cache. Okay, it will continue to build the new cache, the second one, C2. So once it started building the new cache, how long you want me to wait to drop from dropping the existing cache? I'll tell you like this. I have 1,000 records and I got 10 records. These 10 records will be in this cache. And after processing these 10 records, this slice interval will start looking for the notifications. And once there is no notifications, only 20 records added, then this 10 plus 20 will be processed to the new cache. So if you process to the new cache, then you don't need this existing cache. So this interval specifies that how long it has to wait before dropping the old or outdated cache once the new cache started processing. So from the second it started processing, it will wait for 30 minutes max to drop the outdated cache. So that is the dropout cache and the latency time. And here Let's say it started processing the cache 2 and it takes more than 1 hour. Meanwhile, this is dropped after 30 minutes, right? This is the time latency time I have set. If it is dropped in the 30 seconds, now if I execute an MDX query, it reads from here and it goes to relational database storage engine to get the data changes directly. That means it is trying to get the real time even though there is no cache data available by directly querying the relational database what changes. So during the processing of the second cache and after dropout of the first cache, it takes the help of relational storage engine to get the changes, but it will make sure it is giving continuous pseudo real-time data to the analysis server users. So this is the drop outdated cache option. So you have to be very careful here. Once the second cache is started processing and how long it has to wait to drop the first cache. And let's assume it takes more time than 1 hour and this is set to 30 minutes and it will be dropped after 30 minutes. So that moment it will query the relational database directly for changes. It uses the storage, relational storage to get the changes occurred from this moment to until this cache is ready. So this is about drop outdated cache. Let me erase the drawings, it became messy. And now if you see the next option, update the cache periodically, this is the one which we have seen here for scheduled MOLAM. So automatically it won't worry about the notifications, it won't care about the notifications here. What it will do here is it will directly process the caching for every 1 day or for every 2 days, whatever the time frame or rebuild interval you specify here. It will wait for that time and it will automatically, it won't care about the data changes or notification whether the data is changed or not. It directly process it for every 2 days in this case, or you can set it for every 2 hours, every 2 minutes. 2 minutes is too bad, or 2 seconds is too bad to select, but you can set some update the period cache periodically option, and the rebuild interval plays a major role. It will wait for 2 hours and it will process, and then it will wait for 2 hours, it will process. It won't check whether there is any slice interval, silence interval or silence override interval out there. This happens periodically without any break. It's a scheduled automated one. We don't need or it won't look for any notification stuff. The next one is bring online immediately. If you check this one, when the cache is being built, okay, once the silence interval is met or once the silence override interval is met and the cache build is in process, that means reading the changes to the cache is happening. During that time, the queries will be directly triggered to the relational database. If you check this option, bring online immediately, means it will always brings the data that is available, the changes that are available in the relational database without any delay. During the processing of the caching or reading the data changes into the caching, it queries the SQL server or the underlying database to get the changes. So it's always close to pseudo real time. So that is this option, bring online immediately. And enable rollup aggregations will help in creating the aggregations on the relational database side if required. Like for the data changes happen, it can create aggregations on the relational side, but make sure the service account which is used to run and start the service analysis services should have, that should have access to create materialized views in relational database, because for aggregations, analysis services creates materialized views on the relational database. Okay, materialized views or indexed views, right? I think you have an idea about it. So if it doesn't have an access to create the materialized view, then the processing will fail. So make sure that the account which we are using to start the analysis server or to run the analysis server has the access to create materialized views, or else you'd better uncheck this option and apply settings which is disabled. And if you check this guy, normally what will happen is the same settings will be applied to all the related dimensions. What are related dimensions? If you take the measure group here, this will be related to few dimensions, all the dimensions. So everything, the same settings will be applied to all the dimensions. So these are the different options we have on the general tab if you go for proactive caching. Okay, I set it to molap. Let me set it to 10 seconds and 10 minutes here, and drop outdated cache, leave it as is. Now let's see how the notifications works. This is also an important one. So if you go to the notifications, oops, something went wrong. Let me check that. Molap options, enable proactive caching. You must set notification processing time of each. Oops, I've not selected partition. That is why it's saying that it has taken the general one. So I need to select here, click here, options, select proactive caching. Now you can see the general under notifications enable, and let me set the silence interval for 10 seconds and drop out it cache for 30 minutes. And if you go to the notifications, bring online data immediately, and if you go to the notifications, you can see three different types of notifications. The first one is SQL Server, and if you select this, it uses analysis services uses specialized trace methodology, okay, to capture the changes that has been happening on that's happened on relational data side. So if the relational data side any changes are happened, then analysis server will be notified, analysis services will be notified, and the only thing you need to do is you need to select the right tables here. So what are all the tables that you are looking for? If there is any change in this particular table, that means you can select multiple tables too. Let me select the fact internet sales here. Now if there is any change happened on this particular fact internet sales table, then it will be notified to the analysis services, and it will be checking very continuously, and whenever there is a change occurred, then it will notify the cache settings here. So the first notification will be heard by this silence interval, and it will wait for 10 seconds, and if it doesn't hear the next notification within 10 seconds, then it will process the caching. Or if it hears the second notification about the data changes occur, then it will wait for 10 more seconds. So that is how these two coordinates. And the second one is client initiated. This is like you need to treat, I mean, the analysis server client will take care of the notifications, and I mean, like whether there is any data changes in the particular table or not. There is an XML command, notify table change. If I go here, Google XML, so you can see there is an XML command, notify table change. So this is how the sample syntax is. So this will be executed either from your SQL Server integration services or XMLA to find out whether there is any changes happen to a particular table or not. So this takes the help of that XMLA command to get to listen to the changes happening to the table that is selected in the specified tracking tables list. For example, if I select fact internet sales here, then it will use that XML command methodology to find out whether there is any changes happen in the underlying database table. Okay, so that is the client initiated. So it is initiated not by the SQL Server trace mechanism, but this is by the XML command from the client analysis server side, right? So we call it as client initiated notification mechanism. But this is SQL Server. It uses specialized trace mechanism to find out whether there is any changes occur in the underlying table, that is fact internet sales. If you select multiple tables, it will be like a semicolon separator. It will be something, it looks something like this. It will look for all these tables for changes, and if there is a change occurred in any of the table data, then it will notify the update cache settings here. Then it will start, the timer will be started. So that's how it works. And the third one is scheduled polling. It's a continuous queries triggering, like for every 10 seconds. The queries will be triggered and it will get that information. And if you enable incremental updates, what will happen is it will have basically two queries. One is polling query and another one is processing query. So if you check this enable updates and if you don't specify anything in the table given here, then what will happen is the polling query will be linked to the table that is used to create the partition, that is fact internet says. It will link to the table in the data source view and it will continue to get the maximum value, maximum key value. For example, let's say I created a partition on top of dim customer table. Okay. Then in that case, the polling query will be connected to the dim customer table in my data source view. And what it will do is it will execute the following queries, like it will try to get the maximum key value, something like this. Let me show you an example here. I'm connecting to SQL Server and let me go to AdventureWorks DW. Select max of customer key as last cust key from dim customer. So if I execute it, what it will do is it will normally give you the maximum value, right? So this query will be triggered by the polling query. Polling job will trigger the last query, and let's say it triggered at current time. So after 10 seconds, again it will trigger the same query, and let's say here the value is 29500. Here the value is 30,000. So here there are two values, the last value and the current value, last maximum value and the current maximum value. So then you can see it here some changes. There is the difference in the last maximum value and the current maximum value. So what it will do is it will send these two values to the processing query. So what processing query will do is processing query will fetch select star from dim customer where customer key greater than the last value, that will be a parameter, and customer key less than or equal to second parameter. So the first parameter will be the last execution maximum value and the second parameter will be the the current execution maximum value. So it will fetch the processing query will fetch only the changes that has been happened. So this is one way of getting only the changes. Okay. Or if you directly check this and if you leave it, then the analysis server will take care of. The polling query will be linked to the table in the data source view and it will try to find out the changes compared to the last polling query run and the current polling query run. And if there is any changes detected, then it will execute the processing query to get the data. Or you can provide the query here. So this is your processing query. Sorry, this is your polling query. And you can see this has taken the table name which is in the underlying underlying partition definition. And here, this will be your processing query. Something like this. It will assign those two values automatically to the query and it will get only the changes that happen on the particular table. So here you are explicitly specifying what is the table that you should use for polling and what is the table you should use for query processing. So once you specify this, then for every 10 seconds it will be checking. So the last 10 seconds before whenever the polling query executed, the value that I got is the last polling query value, and the current execution will give current polling query value. If there is any difference between these two, then this processing query will be triggered and it will get the data and it will say there is a changes available and these are the changes available. Then this page will decide when it has to process, like whether it has to wait for next notification, or it can process immediately, or it can process periodically. So this page will decide when to process and this page will decide whether there is any data change or not. So if you see, this is for incremental changes, right? You can also do for full update, and it's more like in that case the query will not be this. The query will be count of records. So it will get the count of records in the last execution, and again the same query will be executed in the second, after 10 seconds based on the time interval argument. So if there is any difference in the count, then what will happen? It will read everything. This is full execution, more like full execution, right? It will read the complete data and it will process the data. So either full process or incremental process, but people prefer to go with incremental process. And if it is incremental, it should be like select the maximum value in the polling query and compare it with the last execution and the current execution. And if there is any changes, then the changes will be notified and the cache will be updated. Depends on the silence interval and silence override interval we set on the general tab. So these are the different types of notifications, and about the different storage modes, what you can set and what you can prefer. So instead of having all these things, you can simply select the option here. If you select to schedule molap, it will take care of schedule molap. You just need to modify this, and the thing you need to set here is the notification type. And most of the cases people prefer to go with SQL Server notification type. Very rare cases people prefer schedule polling and client initiated. And you can also select automatic molap, medium latency and low latency molaps. And if you see here, you need to set the notification here. Okay, so currently SQL Server, and you can select the table, and that will set everything, and it will be doing the job. So what I suggest you guys here is forget about all this stuff, and let me go to the custom settings and select molap, enable prior to caching, set one by one. Let's try this by setting the notifications to SQL Server and select the right table like fact, internet, sales, or whatever you are pointing to in the partition. And here set the silence interval and silence override interval, and try to add a try to add a record in your SQL Server in the fact, internet, sales table, and come and see after 15 seconds or 20 seconds whether the data is showing in your MDX queries or in your queue. So that is how you can test this storage proactive caching option. So this is how you can set the proactive caching for a measure group. And the same way, if you go to the dimensions, because most of the cases dimensions will be molap, most of the cases. I said right, if the users want to go with rollup storage mode, they'll select molap as dimensions as molap and partitions as rollup. Here you can see proactive caching. If you enable this, you can see the same page again, the same options and everything. Okay, so you can set the proactive caching at the dimension level and at the partition level, and you can set the storage mode at the dimension level and the partition level. And if you want query performance to be good, molap is best. If you want real time, rollup is good. If you want both, molap with proactive caching will solve the purpose. So this is about the storage modes, and in next session let's discuss about the calculations and the remaining tabs on the cube designer. Thank you very much guys. Catch you in next session. Bye bye.